Have you ever really stopped to think about what happens when things collide? Like a bowling ball just obliterating a set of pins, or that heart-stopping split second of a fender bender. We see this stuff happen all the time. Well, today we're going to pull back the curtain on the invisible force that's running the show in every single crash, bump, and impact. And believe me, it's way simpler and a lot more powerful than you'd think.
So let's just get right into it. What is actually going on in that moment of impact? I mean, it looks like total chaos, right? But underneath all that mess, there's this really simple, almost elegant transfer of something called energy. And once you get that one little concept, it kind of changes how you see, well, everything.
And yeah, that's the key right there. It all boils down to one single event, a collision. I'm talking everything from a distant star going supernova down to you just clapping your hands. It's that one moment where the story changes, where one object passes its energy to another in a way you can actually see and measure.
Okay, so to really get a handle on that transfer, we need to introduce the star of our show, energy. Now, try to forget everything you think you know from energy drinks or your power bill. In the world of physics, energy is basically the currency of change. And a collision? Well, that's the moment it gets spent.
So energy is, at its core, the power to make something happen, to cause change. But here's the absolute most mind-bending rule about it. You can't create it, and you can't destroy it. It just moves. Think about that. Every single bit of energy in the entire universe has been here from the very beginning, and it'll be here at the very end. It's just getting passed around, endlessly.
All right, so energy comes in a couple different flavors. You've got potential energy. Think of that as stored up energy. It's like a slingshot pulled all the way back, just waiting. Then you have kinetic energy. That's the energy of motion. It's the rock after you've let go, flying through the air. One becomes the other.
Okay, so we've got these two types of energy. How does this all connect back to a collision? Well, it all comes down to that single moment of transfer. This is the handoff. It's the precise instant that the kinetic energy from the moving object gets passed over to the other one.
You can actually break it down into 4 super simple steps. 1. The approach. That's the moving object, and it's carrying kinetic energy. 2. The impact. The moment they physically touch. 3. The transfer. The energy gets handed off. And finally, 4. The result. The second object now moves or changes because it's been powered up with that new energy. Approach, impact, transfer, result. It happens like that every single time.
This is the perfect way to think about it. It's not about losing something, it's just about relocation. That kinetic energy that was in the bowling ball, it doesn't just vanish into thin air. Nope. It moves right into the pins and sends them flying. The energy just found 10 new homes to live in.
But, of course, there's a little more to the story. What happens after the crash? To get the full picture, we got to look at the aftermath, because that's where we find out where all the other little bits of energy went. It's almost never a perfectly clean, silent transfer of just motion.
And this is a really, really good question. I mean, if you roll a toy car into another one, they don't just keep rolling forever, do they? It feels like the energy just sort of fizzles out. But we just learned it can't be destroyed. So if it didn't all turn into motion, where in the world did it go? And the answer is transformation. That missing energy didn't vanish at all. It just changed its costume. Some of it became sound. That's the crack or the thud you hear. Some of it turned into heat because of friction. And a whole lot of it often becomes what we call deformation. That's the energy it takes to physically bend or dent something. Every single drop of that initial energy is accounted for. It's just wearing a different disguise.
Once you really get this simple idea of energy transfer, I promise you, you will start seeing it absolutely everywhere. This isn't just some dusty concept in a physics textbook, it's happening all around us all the time.
Let's take sports. That incredible, explosive crack when a bat connects with a baseball. That's not just the sound of some wood hitting leather. That's the sound of a massive, super fast transfer of energy. All the kinetic energy from that bat swing gets violently jammed into the ball, sending it soaring.
Or, hey, what about music? A drummer is basically an energy transfer expert. They move energy from their arm down through the stick and slam it right into the cymbal. The cymbal vibrates like crazy, turning that kinetic energy into the sound energy we hear as that big crash.
And this one might be the most important of all. This very principle is used in safety engineering. A car's crumple zone is a total masterpiece of energy management.
It is designed on purpose to absorb the kinetic energy of a crash by getting destroyed. Every dent, every bend you see on a crashed car is energy that went into changing the car's shape instead of being transferred to the people inside. Understanding this physics literally saves lives.
So let's end with a really big idea to chew on. If every single motion, every sound, every impact we've ever seen is just energy moving from one spot to another, an unbroken chain of transfers stretching all the way back through time, well, that leads to one pretty profound question. What was the first one? What was the original collision that kicked this whole thing off? Something to think about.